Thank you, everybody, for joining us. It looks like we have a very diverse crew visiting our crew today. We have people from Brazil and Tokyo, Philippines, Indonesia, MIT, Uruguay. So thank you all. Some of you, I know it's very late at night for you, and we really appreciate you joining us. So welcome. My name is Kirkita Long, and I'm the Assistant Director for Special Projects here at JWell. Welcome to today's webinar. This is in partnership with Learning at Scale. Today's webinar is titled Effective, Secure, and Efficient Summative Assessment Using a Computer-Based Testing Facility. To give you a bit of context about the series that we've been organizing, as we know, by April of this year, about 1.7 billion learners from K through 12 and higher education were out of school due to the COVID-19 crisis. And this was a big issue. We know that many countries, many institutions had to pivot in a heartbeat. They moved to remote solutions or blended learning solutions. We thought this series would be great at promoting a conversation about what has happened, what we have done, what we're planning to do, but to also talk about the research and how we're planning to use the research as we create the solutions going forward. None of us know exactly what's going to be coming in this next year, but hopefully it's going to be better than this past spring. So today we have with us Professor Craig Zilles. He's Associate Professor and Education Innovation Fellow at the University of Illinois. Welcome, and thank you for joining us today, Craig.
Thank you so much. Yes, I'm Craig Zilles. I'm a faculty member at the University of Illinois, and I'm going to tell you a little about what we call the CBTF, the Computer-Based Testing Facility. So I'm going to start with a little motivation. I'm going to explain what the Computer-Based Testing Facility is. This is not something that's going to translate directly to our current COVID situation. But I'm going to walk you through sort of the organization of it, what our exams look like. This may be very relevant to what you want to do in COVID. I'm going to talk about the fact that with the CBTF, we ran asynchronous exams and what that means for student behavior and how much randomization we do in our exams. That turns out to be a very important component of our strategy is randomization. I'm going to talk about some research that we've done relating to how increasing testing frequency has led to improved learning outcomes. And then I'm going to talk at the end about our transition to online exams and how we've taken the pieces of this strategy to build the strategy we're using for our online exams this past spring and going into the fall. So I do encourage questions, so please put them in chat and the people monitoring the chat will ask them. But I'm going to talk about some things that may be very different than what you're used to. And so please do everyone else in chat a favor by asking the questions that they also have. All right, so what is the motivation for the CBTF? The University of Illinois is a very large engineering school. In the US, we're the second largest by the number of bachelor's degrees that we graduate. And that means a number of our foundational classes in computer science and engineering are very large, that we have to, in order to graduate 2,000 bachelor's degrees every year, we're processing roughly 1,000 students per semester in the calculus-based mechanics sequence, 800 students in our data structures course, and 500 students in a bunch of our introductory statics and dynamics courses. And these large classes make traditional exams a pain, that when you have hundreds of students, the printing and proctoring across many rooms, dealing with student conflicts and illness, testing accommodations, that's a lot of grading. It's hard to grade consistently when you have that many different students. The feedback's potentially slow, or you might have heavy reliance on multiple choice. Basically, testing is sufficiently painful that most faculty don't do it very frequently, which a lot of research suggests is bad for student learning, that things like the testing effect encourage students to build long-term retention of the material. And so what we were looking for was an assessment strategy that scaled to large populations without sacrificing quality. So we're not only a large institution, but we're a relatively strong institution, and we didn't want to dumb down our classes just because they were large. So our strategy was the computer-based testing facility, and this really has two parts. One was the ability to build sophisticated computerized problems, that we were going to shift running our exams onto computers, but we didn't want to dumb down our exams. We didn't want to go to multiple choice. We wanted to still ask the kinds of engineering questions that we had been asking on paper. And so we built a tool. My colleague Matt West in the mechanical engineering department built what's called PureeLearn. It's an open source tool, and it allows us to build sophisticated computerized problems. I'll show you some examples of them. One of the keys of this is that it allows us to randomize the parameters. So in general, when we write questions, we don't write individual questions. Instead, we write what are called item generators in the literature. Basically, it's a piece of text along with a piece of code that will generate different versions of the problem. Furthermore, it allows us to auto-grade a wide range of problems. And again, I'll show you examples of this. But basically, it can do most of the things that we want to do, at least for low-level skill building. So we can do numeric questions, we can do symbolic questions, we can do code writing questions. And here's just a brief view, and again, I'll show you in more detail, but we can do programming questions, we can do symbolic answering questions. Here's one where they answer in a matrix. We can do questions that involve drawing. The key thing is that we wanted the full feature of what you could do in a web browser in our ability to ask questions. So that's part one. And part two was a secure computer lab, that we wanted to be able to verify that, in fact, the person who is claiming they were doing the work was the person who was doing the work. And so we converted a computer lab into our computer-based testing facility. Physically, there's not that much differences. The main differences are that it's proctored, and that we control the networking and file system on the machines so that the student doing the work is actually, we know it's actually the student that's doing the work. And so this room has 85 computers in it, and we run it when the CBTF is open, 12 hours a day, 7 days a week. This fall we would be entering our 6th year, that we've been running this for quite some time. It started in fall of 2014 with just my class, and basically we've had linear growth in the number of classes. And you can see this color coding here, that there's a significant diversity of the departments that are using the computer-based testing facility. We've also had significant growth in the number of students. So as of last fall, we had 35 different courses that were using the facility last fall. That, again, starting from just my class in fall of 2014, we've gotten to the point that we're consistently running 50,000 exams per semester. Last fall, we ran over 75,000 exams because of the additional courses, and that was for almost 9,000 unique students. So the key thing I want you to take away is that we've been doing this long enough that we sort of figured out how to make this scale. So become a resource that faculty can rely on and address more and more faculty. So the key thing is it's changed the way we test. That one of the big problems we had before with paper tests was that, again, it was so much of an effort to run an exam that people didn't do it very often. With automated scheduling of the exams, having the proctoring done by professional proctors, and having a lot of the questions automatically graded, that makes it almost free to run exams once you have generated the content for the exams. And so what this has done is it lets faculty shift from very infrequent testing, where each of these midterms historically might have been worth 15 to 25% of the student's grade, and so it was very stressful, to a strategy where we've distributed the testing across the semester. So maybe every 2 weeks there's a new quiz that's worth 10% or less of their grade. And so each of those events ends up being less stressful for the students. And then again, because testing is basically free for us, many of our courses do what's called second chance testing. So maybe the week after an exam is offered, if the student didn't perform very well, or at least didn't perform to the extent that they wanted to, they can go away, learn the material that they didn't perform well on that exam, and come back and take another instance of the exam for some form of grade replacement. And so I'll show you some data at the end, but we've seen this being a key strategy for helping students that would have earned maybe D's or F's perform better in the class, because they have a motivation to go back and learn the material that they missed. I'll pause. Are there questions so far? Or great. So when assessment is cheaper, people tend to do more of it. So so we've surveyed faculty. This is sort of a telling quote, that this has revolutionized assessment in my course. It is much more systematic. The question quality is much improved, and my TAs and myself can focus on preparing questions, that is, improving questions rather than grading. So again, our strategy is the development of these question generators rather than individual question items. And because of that randomization, you can use that same question generator semester after semester. And so rather than each semester having churn where you're like, oh, I need to come up with new exam questions and worry about proctoring them and whatnot, that what our faculty work on is either adding new kinds of items that they didn't add previously, or going back into the exam the previous semester and saying, okay, which items didn't perform quite as well as I'd like, and improving those items. So we see significant reported reduction in effort to run exams and significant reduction in grading load. And what that does is it frees up staff time for higher value activities. So rather than spending your TA time and faculty time redeveloping exam questions, proctoring, and grading, we can spend the human time holding more office hours and reintroducing more open-ended projects or lab reports with that time, or spend that time adopting more active learning pedagogy. So our key goal with the CBTF is not to replace humans, it's just to automate things that can be improved by automation to free up the humans to do the things that we can't automate effectively.
So we had a question.
Yep.
From Dr. Muhammad, I'm going to screw up your name and I apologize, Akhtar. How can we manage to provide classroom training where there is no internet connectivity and tools available in different countries? There was one report that 47% of the students have no internet facilities globally. Even in India, 50% of the students are deprived from 3G or above broadband connectivity. Are you facing the same problems? Is any emergency technology resolving these problems?
So that's a great question. So the thing that I'm talking about, the computer-based testing facility, is a physical facility. So because of COVID, it's closed, but it doesn't rely on students having their own computers or any broadband access at home. That the students will physically come to our facility to do their testing. So this is not designed, this is designed for residential university campus. That what you're saying, what your question you're asking is a great one, but it's not one that I have any particular answers for.
We have another question, was whether this could be adopted for other specialties like medicine and biology.
It certainly could. I think our experience has been that that anything sort of in the STEM domain. So the virtue of the STEM domain is that often, at least for a significant chunk of the material, there's objective answers for things. That key to writing an autograder for something is being able to define what is correct. And that's much easier for things that have objectively scoreable answers. So we've seen nutrition do this, you know, biochemistry, chemistry, physics, any sort of STEM-ish things. I think you could also use this kind of facility as a way for securely running, you know, things that you don't attempt to auto grade, but some of the value comes from the auto grading itself. And so in some domains, it'd be harder to auto grade, for example, English essays, although there's people in the NLP world that are working on that also. Great. So let me tell you a little about the operational details, what the CBTF looks like. Before I do, I just want to make clear that this isn't something that I alone did. I am one member of a big team. So my colleague, Matt West, is a faculty member in mechanical engineering. He helped start the CBTF and also is the primary author of the PrairieLearn tool that I will demonstrate. Dave Messelman is a member of our engineering IT team. He's helped a lot of this developing sort of the back end software and some of the working with faculty. We have currently a full-time coordinator for the CBTF who manages personnel for the proctors and interacts with the faculty. There's a number of people, Nathan, Tim, and Mariana have contributed significantly to the PrairieLearn tool. Mariana and Jeffrey Herman are faculty members that have contributed to some of the quasi-experimental studies that I'm going to show you details for. And Binglin Chen is a graduate student that is advised by Matt and I, who contributed a lot of the analytics of some of the data that I'm going to show you. I also want to point out that this is not a thing that's unique to the University of Illinois. So Ron Damara, shown here at the University of Central Florida, is receiving an award from his university for basically setting up a similar thing to what we've done at Illinois. He calls his the Evaluation and Proficiency Center, but this is definitely an idea that generalizes to lots of different situations. All right. So how does the CBTF work? One of the key things is that we run our exams asynchronously. So that means that not all the students in a class are taking the exam at the same time. And there's two reasons for this. One is we don't have enough computers for a class of 800 students to take their exam all at the same time. So just for cost, it's important to allow students to take exams at different times. The second reason, I guess there's three reasons. The second reason is students have conflicts, and one of the big overheads of running an exam with lots of students in it is dealing with the need for conflict exams. And so we just sort of said, okay, every exam is a conflict exam, and we let students pick a time. The third reason is that students love the ability to have some flexibility in when they take their exam. So we give students a range of days, so 3 or 4 days, and our facility is typically open 12 hours a day. And we have an online web-based scheduler tool that the students can go and they can pick a time that they take their exam. So they need to make a reservation because we need to make sure that we have a seat available for them. So you can see some of these times have filled up, and so students can no longer select those times. But they can make a reservation. If they change their mind, they can go and they can change their reservation. All of that happens without any email or interaction with faculty directly. And again, students love this. A common thing is that they may have another exam on the same day that you might have given your exam, and they can choose to put their exam on a different day, for example, so they can manage their time. Once they've done that, then they come to the CBTF, at the appointed time. And our goal of the CBTF is to provide a secure, supportive environment. So the security is super important, that ultimately we want to know that, in fact, that this is the student whose work we're evaluating. So the CBTF is a computer lab. It's proctored, and the proctors verify the student identities at check-in. So the students bring their student ID and we swipe them, and we also additionally have photos in our system to verify the student's identity. The seating is randomized, so we assign seats, so all of the seats have numbers associated with them, and we assign people in the CBTF to their seat. And in general, there's many exams running concurrently, and so you may have 5 or 6 different exams going on in the room at the same time, and we try to seat people next to people taking different exams. So even if I was to lean over to look at your screen, you'd probably be taking a different exam. We have the students leave all of their stuff by the door. That basically, we don't let students bring anything in except a pencil. No paper in, no paper out. Students are provided with blank scratch paper and a calculator. So they have all of the things that they should need along with the computer to take the exam. The computer's networking is restricted, so they can't go to, Stack Overflow or instant message their friends. And they have a clean home directory, so there's no files left over from anything. Proctors are present to monitor the exam and assist with any hardware problems. So if when we run 75,000 exams in a semester, sometimes a machine dies during the exam and we need to pick a student up and move them to a different computer. The proctors don't help with clarifying questions. So it's super important that the questions are clear, because the proctors are not your TAs, they're not you. They can't ask or answer questions on content, but they can document exam problems. So if a student does have a problem with the exam, the proctors can help document that problem so that when that can be presented to the faculty member after the fact. Exams are graded interactively, so you can, while you're taking the exam, say, I'd like this question graded, and it's graded on the spot. This is key because we allow multiple attempts for partial credit. So it turns out that it's very hard with an auto grader to assess partial credit in most cases, and a strategy that we've found to be very effective for giving partial credit is to just allow the student to attempt that same question again. You haven't shown them the correct answer for either the same amount of credit or a smaller amount of credit. So if they made a sign error, or they can go back and check their arithmetic, and they can get some fraction of the points. The faculty member or instructor controls that partial credit schedule. Proctors are in charge of enforcing time limits, and students leave knowing their score. So by the time of the end of the exam, they've graded the exam completely. They know what they got on the exam. They know which questions they got wrong. They can look at what would have been the correct answers in many cases. So they get immediate feedback. And we were initially somewhat concerned about this, that we would thought a student that didn't perform very well might want to not know right away that they had performed not very well. But what we find is that most students would like to just pull the Band-Aid off quickly, that it doesn't help having a week delay to know that you didn't do well, that they do in fact like the immediate feedback. And we do have security cameras present, and then that mainly is used for documenting academic integrity cases. So if a proctor notices something funny going on, a student snuck in some piece of paper, they pull out a cell phone, which they're not supposed to have in the CBTF, they can go back to the security camera footage and document, oh, here's where they pulled their cell phone out and put it between their legs, and so on and so forth. And initially, we were concerned about having security cameras in the facility because we thought it would feel like, kind of a prison environment. But it turns out that in general, the students are actually quite positive about our security precautions. Our findings are that the vast majority of students want an environment that doesn't reward cheating, because they don't want to feel like they have to cheat to keep up with their fellow students. And so in general, the security cameras haven't been a problem.
We have a couple questions.
Great.
So Ryan Haraparmana asks, in the previous slide, Craig mentioned an assessment method with E1R for repeating if students do not pass the first time. Is that a method applied to all courses?
You can do it on a question by question basis on an exam. So it's not required. In fact, like sometimes on my exams, I'll include a few true false questions, and there's no point in giving multiple attempts on a true false question, because if it's not true, then it's false. And if it's not false, it's true. In general, what we encourage people is to think about how guessable the answer space is. So if you have a numeric entry question, where it's like any floating point number, could be a potential answer, or a programming question where, it's very unlikely that student's going to randomly type stuff and it's going to be correct. You can have a very gradual degradation. So either, you only lose 1 or 2 points per attempt, versus like a multiple choice question where if I eliminate one of the answers, it's much easier to answer the question, that you might have a much steeper partial credit degradation. And I agree with Haynes that the immediate feedback is super important for student learning. And again, in conjunction with second chance testing, where the student during the exam and when the exam is over, they know exactly what they got wrong. They can take that knowledge and go and immediately remediate that material so that they can come back the following week and demonstrate what learning they have. That my feeling is that it's not our job to sort people. I would love to give everyone A's if they could all demonstrate the material, and so second chance testing helps me do that.
We also had a question from Jamila Farsi. Are there any books or materials to build our skills in such an approach to these types of questions?
There's definitely a lot of work that's been done on things like item generators and how to write item generators. I have a couple of papers that have citations to a bunch of things that I can point you to. If you Google CBTF UIUC, there's a research page, and there's 2 papers that I recommend. One is our white paper. I guess I'll show you the paper links in just a second when I switch to the web browser. Is there any other questions? Okay, I'll follow up on that one in just a second. So one of the other big challenges, again, with large classes is dealing with testing accommodations. So typically some small percentage of our students, 1 to 5%, have some kind of testing accommodation. So most commonly, these are things like they require extra time, or they require a reduced distraction environment. We also happen to be a wheelchair accessible campus, and so we have students that are in wheelchairs. And the CBTF, one of our key features is that we handle more than, I would say, 98% of these accommodations without additional effort from faculty or courses. That in the scheduler, the tool they use to make their reservations, at the beginning of the semester, the students bring their accommodation letter saying, okay, this is what the campus has decided the student has needed, to a proctor, and the proctor enters information into the scheduler. And then from that point forward, anytime they make a reservation, we put them in, for example, a reduced distraction environment. So this has partitions. and there's earplugs available so that this blocks the peripheral vision, or it just automatically allows them to schedule a time slot that has that extra time. And so there's no longer a need for us to keep our TAs, an extra hour later after the exam for a few DRES students, for example, or, schedule specific other options. So it makes it much more convenient for handling these testing accommodations. The other thing that's important is how we communicate with faculty, that faculty are delegating running their exams, and exams are a super important part of how faculty teach. And so you don't want to have no idea what's going on in your exams, but at the same time, you don't want, 200 emails after every exam. And so we've walked that line pretty carefully. There's a lot of issues that the CBTF handles itself. So for example, we've had times in running, 6 years that, for example, there was they turned off the lights in the room without notifying us because they were doing some work in the building. And that we try to handle ourselves, or when a machine goes down, we typically just move the student and give them a little extra time. And it's not something that we bother the faculty with. There are some times where the faculty does need some documentation, that if a student says, oh, something really unfair happened to me in the CBTF, the faculty needs to know whether or not to believe the student. And so we've developed a process for how the student can report an issue, and the proctors can document it so that the faculty knows, oh, okay, this was actually a real issue and something that I need to deal with. Cost, I'm not going to spend a lot of time on this. We've done an analysis. It's a little out of date, but it basically comes down to around $2 per exam for, all told, the scheduling, proctoring, paper, and grading. This turns out to be quite a bit cheaper than a bunch of the human online proctoring services. And in practice, on the same order of magnitude as printing a multi-page paper exam. Our biggest expense by far is humans, that the proctors and the coordinators. It turns out computers are remarkably cheap. This does not, in fact, though, count the space and electricity and whatnot. So that would also be a significant expense if it wasn't handled for us. All right. Let me show you a little about what the exams look like. And again, this is using the tool that we've developed called PraiReLearn LMS. This is an example of what the exam might look like. So in this case, the exam's out of 70 points. It happens to have 7 questions on it. And this is that partial credit degradation curve. So the next attempt, they would earn 10 points. If they didn't get it correct on that, on a second attempt, they would get 9, third attempt 7, so on and so forth. The students can navigate through the questions in any order. And then let me show you some examples of questions. Oops, screen share. All right. So again, one of the key things is this notion of question generator. So this is from an intro programming class. It says write a range expression that produces a sequence of values. And so rather than, again, authoring a particular version, if I hit new variant, it will generate different versions of this question. And so if I try to answer this, that it's actually, in this case, I've written a piece of code and it's actually running my code to see if it produces the correct data, which in fact, in this case, it did. So this is one example of a question generator. Here's another. This is from a mechanical engineering class. In this case, they've put a bunch of forces on beams and moments, and each of these has some numerical value associated with it. In fact, we give students MATLAB code that one of the advantages of having students take exams on computers is we can encourage them to use computerized tools for solving it. So we say, hey, you're at a computer, you might as well open up MATLAB and use that to solve your engineering calculations. Here they would type in, the answers numerically and grade it. Thing I want to point out though, again, this is also a question generator. So these numbers, the 75, 146, those will change, but also this picture where the forces are changed. So if you look at it, it's red, blue, blue, red. And if I generate a new version of this question, those forces are in different places. So we have the flexibility of doing that. This is, again, another question generator. In this case, the student's supposed to say what the electrical signal is. This image, again, is being generated dynamically. So if I regenerate it, a different student will get a slightly different version of this question. So I didn't point out why these question generators are so important for us. Again, because our students are taking the exams asynchronously, different students are taking it at different times. If we gave all the students exactly the same questions, then the first student would go in and come out and say, the answer to the question is 7, and tell all the other students. And so we write question generators so that we can give each student their own slightly different version of the question. This is a programming question. This is a much longer form programming question. This is what's called a Parsons problem. So some of these questions, we can, again, take advantage of the fact that we're in a web browser. So a Parsons question is the students can write code by moving blocks around. So they select which blocks are correct. This is sort of a building block for programming classes. This is a question that asks students to draw free body diagrams, so they can actually annotate this, the points of contact in this figure, and it'll grade the free body diagram. This is one of my favorite questions from my friend, the roboticist, that he wants students to understand what this translation and rotation matrix sort of means intuitively. And so he gives a random translation and rotation and asks the students to position this robot. And so I can move the robot around and rotate it into the correct position as specified by these matrices. And this all can be automatically scored. So again, we have the full power of a web browser. This is a question for designing finite state machines. I'm not going to bother explaining what a finite state machine is, but basically I can design a graph and label it, and then we can automatically score that question to see if the graph that somebody built has the properties that we're looking for. And then most recently, one of my ongoing research activities is questions using natural language processing. So this is what we call an explain in plain English question. We're showing the students a piece of code and asking them to describe in English. And so if I say, so in this case, if X is greater than Y, return X, otherwise return Y. So this returns the maximum of 2 numbers. And it says, in fact, I'm correct. But if I say it returns the last element of the list, hopefully it tells me I'm wrong. So those are some examples. Are there questions about, again, our key here is 2 things. One is that we didn't want to dumb down the content of our exams, and the second is that this notion of writing question generators. So you write all of the versions of a question once, and then, you never have to write that question again.
Haynes has a question. Has the CBTF question generator been integrated into an online course or MOOC?
Somewhat. So we have a Coursera-based master's program, and I believe that some of our courses have, some of our MOOC courses have integrated PureLearn. So PureLearn does export I'm blanking on the standard interchange format for educational tools. So there is a way to embed PureLearn questions in the Coursera platform. So that's been done somewhat. Certainly, a lot of our classes are going to be pure online this fall. So we've been we will use even more PureLearn this fall.
The other question we have is, what does it take from the faculty side to develop one of these question generators?
Great question. Some of the questions I'm showing here are the more sophisticated questions. If I go back to this one, the thing that we encourage faculty to start with are, for example, it obviously depends what your field is, but two things that are relatively easy to write. One is this kind of programming question where you just write a prompt, you specify what the starter code is, and then you write a collection of unit tests. So people in computer science are pretty comfortable with that. In non-computing STEM fields, this kind of structure turns out to be pretty good, that what you write a piece of text and you leave some holes in it for where the numbers go. You include in, normally we encourage starting with a static image where you just, take your favorite drawing application and you produce an image. And then you have to write a little piece of code that generates the numbers in the right range. Let me see if I can pull this up. That generate. So there's a lot of things like generate random integers in a given range, and then you write an equation that computes the correct answer, and those are the two pieces that you need for something like that. You need to know what the right answer is if a student enters it, and you need to generate random numbers in an appropriate range. And so it turns out to be not that hard. That the strategy for writing most of these questions is find a question that already is very similar to what you want to do in structure. You copy that question, you change the text, you change the figure, you change the random number generation ranges, and you change the equation that computes the correct answer, and boom, you've got a new question. So once you get comfortable with this, you can write that kind of question, or in this case, this kind of question, typically in less than an hour. And so it does take a good bit of effort to sort of build up your question bank, but that's an investment that pays off year after year going forward. So again, the students can navigate through the questions in whatever order they want. So let me tell you a little about asynchronous exams and student behavior. So I mentioned this before. One of the key challenges of asynchronous exams is what we call collaborative cheating, where you have student A that takes the exam early in the exam period, and then they can talk to student B, and student B can study based on that and then take the exam. And we don't want this to significantly change the score that student B would have earned. And so our key strategy is exam randomization, and we actually do randomization in 2 dimensions. We do that changing the numbers, changing the parameters of the question, but we also use question pools. So we typically write a group of questions on the same learning objective that are about the same difficulty, and set it up so that different students will get a different draw from that pool. So one question that people have about asynchronous exams is, won't the students that take the exam later do better because they have more information? And what we find is actually the opposite, that two things are routinely true. One is that by and large, the majority of students put off the exam until the last possible moment, and that the students' exam scores drop over time. This one's exaggerated more than many of them, but almost universally we see that exam scores go down throughout the exam period. And this makes sense in hindsight, that if you're a student who's very confident and you feel prepared for the exam, you take it whenever it's convenient for you. But if you're a student that's very nervous about the exam, you would tend to put it off as long as possible. We've done some studies to try to understand how much randomness is necessary. So we did a study, and I'm gonna, because of time, gonna go over this at a very high level, and I'm happy to answer questions after the fact. But we ran an exam where we basically had different size question pools, and we wanted to understand how much those question pools prevented students from benefiting from this collaborative cheating. And so, for example, student A may have received these questions, whereas student B may have received these questions. And so we had a way to sort of identify who had received information, and I'm going to gloss over that. I'm happy to point you at the paper. But the main takeaway was that when we gave all of the students the same problem in a pool, people that we had identified as cheaters performed 12% better on those questions, whereas if we had 4 questions in that pool, they performed statistically equivalently. They actually, in our results, performed almost equivalently on pool size 2, but because we happened to put easier questions in these pool size 2 slots, there's a bit of a ceiling effect that the cheaters could only have done 10% better. And so we're not super confident that 2 is enough, but we think that having like sort of at least 3 or 4 different versions of a question is sort of sufficient to make collaborative cheating much more difficult. Let me spend a little time talking about testing frequency and improved learning outcomes.
I had one question about what you just talked about from
Yep.
Haynes. Do you statistically measure how equivalent the difficulty in the replacement questions in the pool actually are?
Yeah, we do. So that's a great question. So there's a tension between the security you get by question versioning and fairness. That it's very hard to make versions that are identical difficulty. So companies like, that run the ACT and the SAT and all the standardized tests spend thousands of dollars per question, making sure that, all the questions have, that they understand the parameters. And those of us in higher education typically don't have that kind of resource. And so the way that I sleep at night, so we do our best to try to make sure all the versions are equivalent. The thing is, I think it's not important that they're of identical difficulty. And the reason why is, if you think about the exams that you run in fall semester versus the exams that you run in spring semester, those are both valid sets of exams. And that you just want the difference between students within a semester to be, on the same order as the difference that you would expect from semester to semester if you were writing new versions of the exam. Sometimes we make mistakes. Our tools are pretty good at reporting the average difficulty of various questions. So after an exam's done, you can go and look at the results, and if there was some question that was significantly harder, you can go and grant points to people who got that harder version. This is an interesting area. It's not a trivial issue. One benefit that we get is because we tend to use, once we've written these question generators, after we've put them on an exam, we have a pretty good characterization of them. And so if we did happen to put, a much harder, a much easier version of a question in a question pool, that we'll take that out when we run that exam the next semester. Great question, though. All right, testing frequency. So one of the things that our faculty like about the CBTF is allows us to test more frequently, as this quote says. As a result, students are staying on top of the material better because of a weekly quiz model, which has made a substantial impact to their learning, but also feeds back to the lecture and lab components of our course. Students are more participatory in these sections because they have not fallen behind. That because they have these every 2 week or so short quizzes, less than 50 minutes, that it encourages them not to procrastinate, and that, that since a lot of our classes build on the material week after week, that having them, assessed, in a serious way on the material more frequently tends to have them keep up. So we've done 2 experimental studies. I'm only going to tell you about one of them because of time. In both of them, though, the same class, same instructor, different semesters. The only change in the class was shifting assessment activities to the CBTF. And so one of the key things about the CBTF, again, it enables more frequent and reliable assessment, that we in fact know who's doing what. So what we're doing here, I'm going to report scores on an unchanged pencil and paper final exam. So in the control semester, all of the exams were in pencil and paper. In the treatment semester, the midterms were on the CBTF, but it still used a final exam that was on pencil and paper. And so there's no mode advantage for the CBTF. In fact, there's a mode disadvantage. And we think these final exam scores are a better proxy for student knowledge than their overall course grade, because course grades often include some effort components. So this was in an introductory solid mechanics class, and they replaced 2 midterms with 5 quizzes, roughly the same amount of material, just broken up into smaller pieces, and then offered 5 second chance exams. And what you can see in blue is the percentage of students that on the final exam got D's and F's was close to 30%, whereas with the more frequent testing schedule, it was less than 15%. So we saw a drastic reduction in D's and F's on the final, and you also see a drastic increase in the number of A's. So, that's pretty compelling. One of our beliefs is that more frequent testing ends up getting more aggregate studying from students. There's only so much you can study for an exam, but if you have twice as many exams, students end up studying a little more because it's just distributed over the semester. So I'm going to skip over that. I mentioned second chance testing. I'm just going to show you some quick results on that. That one of the key ideas of second chance testing is that understanding course expectations is one of the hard things, and understanding whether they're prepared, that sort of meta knowledge of like, am I actually ready for this exam? What I'm showing here in yellow and this reddish purple is the score distribution students would have had if they, on their first attempt. And then the blue and purplish is the shift of the distribution after we've done second chance testing. And so what we tend to see is it pulls up the bottom part of the curve, that again, these sort of low D and F grades, we have many fewer of them, and it pushes more people into the B and A range after they've had an opportunity to demonstrate that knowledge. All right. going to spend my last minute or two talking about how this relates to what we're doing now with our online exams. That it's really hard for us not to be able to use the CBTF given COVID. It was just such a solution to a big problem in our instruction, that we view online exams being creating a tension between security, cost, and invasiveness. So here's a list of recommended security techniques. I've listed some in green and some in red. The ones in green are the ones that we do. So time restrictions that basically, if without time restrictions, so we run time restricted synchronous exams. Synchronous meaning all the students are taking the exam at the same time. And one of the main reasons for that is to prevent students in the class at the same time from helping each other. That if they're all responsible for doing the exam at the same time and there's a limited amount of time, then they need to focus on their own work instead of spending a lot of time helping each other. Again, the randomization is super important. So if different students have different exams, the student can't just share, oh, the answer to number 3 is 7. Higher order items, you want items that students can't just put into Google and get an answer for. So Prairie Learn lets us ask more sophisticated kind of questions. And also in our shift to online, we've added a cheating statement. So basically at the beginning of the exam, it says, I agree not to cheat on this. And that's been shown to deter some cheating. Some of the things that we don't do, one of the things that's been suggested for online exams is blocking backtracking. Basically, you have to do each question, and when you move on to the next question, you can't go back. And that is one strategy, but we felt like that was too much of a departure from pencil and paper to, it was this sort of invasive thing that it was going to be detrimental and more stressful for the students. Also, so far, we haven't encouraged the use of lockdown browsers. We had a lot of pushback from students from the sort of perceptions of spyware, and in an online environment with students having so many devices like cell phones and tablets, that even if we lock down their laptop, they have other ways of accessing the internet, for example. Another thing that's been encouraged is deferred feedback, where you don't tell the students what the answers to the questions are. We think that goes in the face of student learning from immediate feedback, as well as our opportunities to allow them to submit multiple times. Proctoring, we do very light proctoring that I think it's not quite security theater, but because we have this collection of proctors and some mechanisms for scheduling exams and whatnot, we're deploying our own Zoom-based proctoring for the summer and fall, but it's much lighter weight than what you might get from a commercial service. That we're mostly relying on the synchronous and randomization to get exam security. So I will stop there because we are past time, but I'm happy to stick around and answer questions.
One question was, what percentage of your exams got moved over into Prairie Learn?
So that's a great question. So I think one of the key things to think about is that Prairie Learn, and in our case, the CBTF, doesn't have to be your complete assessment strategy. So it's really good at sort of the low-level building block skills. It's less good at the integrative kinds of activities. So we've seen a lot more usage in our 100 and 200 level classes with freshman and sophomore level classes. That many of our junior and senior classes are much more project oriented. But also over time, I've shifted more and more of my content in my classes to Prairie Learn as I've had the time to develop the more sophisticated things. So the class that I'm teaching, so I this past year I've been teaching an intro to programming for 600 non-technical majors. And for that class, that right now all of the assessment is done through Prairie Learn. Once we've built the content out, I'm looking to introduce projects, so that's, you know, that's at one extreme for a 100 level intro to programming class. But there's definitely classes that do a mix of paper exams and computer-based exams, at least back when we had actual face-to-face classes.
Thank you. I think that's all of the questions. We want to thank everybody for joining us today. If you have a moment, please follow the link in chat and fill out the quick survey. I think there are 4 or 5 questions to get feedback. But thank you very much, Professor Zilles, for joining us. This has been amazing.
Thank you. And again, I forgot to follow up on, so if you Google CBTF, CBTF UIUC, so this URL, cbtf.engr.illinois.edu, will bring you to this page, and there's a page called Research, and there's the two papers here are, if you're interested in learning more, these are your best resources. This first one, called Every University Should Have a Computer-Based Testing Facility, is a high level, what we call a white paper, and that has a bunch of links of, like, you know, how this thing works and the philosophy in general. The second one, Making Testing Less Trying, basically is a deep dive into how the CBTF works. So those are the 2 places that I would start, but we have a whole collection of research on this.
Thank you. Thank you, everybody.